All right, ladies and gentlemen, this is the last example that we're going to look at in section 5.1. Now, this example we've been over several times in this class, but the reason we're looking at it again is this material with creating a model, creating your own model, is a little bit harder than somebody giving you a function and telling you it's a model, all right? If you took somebody, for example, who worked for an insurance company or worked for, let's say someone, Geico hires mathematicians, statisticians. Those people are usually called actuaries. And if you're in actuarial science, you basically have a degree in math and a degree in statistics. And you come up with functions for insurance companies so that they're charging people the correct rates so that they're still making a profit. And a lot of that has to do with, basically what's going on in that particular town. Where do, what industries are there? What are the age of the people? What are the accident records? What are the health records? So those people create those models. We're going to create our own model here on obviously a much simpler basis, but we're still doing the same thing. The sale of SUVs increased dramatically between 1991 and 1999. In 1991, the sales were about 1 million. In 1999, the sales were about 3.2 million. Growth in sales for this period was roughly linear. So that means we can use the linear model y equals mx plus b. And the way and in fact it asks us to. It says find the values of a and b such that f of x equals ax plus b models the data. A in this case is the slope and b is the y-intercept. Now, what I want you to remember from past problems that we've done like this, we're going to let x be the number of years from 1991. And we're going to let y, which is the output, be the number of SUVs that were sold. But instead of being ridiculous and writing out 1 million with all those zeros, why don't we just say that our answer is measured in millions? Okay? So the first piece of data then becomes very easy to write. In 1991, sales were approximately 1 million. Well, in 1991, you were 0 years away from 91. And your sales were 1 million approximately, which we're going to call 1. There is how we got the ordered pair 0, 1. In 1999, how many years is that away from 91? Obviously 8. That's why the first entry in the ordered pair is 8. Sales were 3.2 million. We've agreed to leave off the million, so we have 3.2. So the ordered pair is 8, 3.2. I need to find the slope. I call it m because that's what you're used to, but when you plug it into their formula, you call it a. Something I want you to understand, it's, some students like, well, how come they change it on us? One time they call it m, one time they call it a. They're getting you ready to use a graphing calculator, and in a graphing calculator, when you're entering a function, or in statistics, those of you going on into statistics, when you're using linear regression, which is a process that the calculator will come in handy for, they don't call the equation of the line y equals mx plus b, they call it y equals ax plus b. So just realize the number in front of the x is always the slope, regardless of what you call it. So remember how you find m. Change in y, which is what that triangle means, change in y over the change in x. So I subtract the y values on the top, I subtract the x values on the bottom. 3.2 minus 1 becomes 2.2. 8 minus 0 becomes 8. 2.2 divided by 8 is 0.275. So I know that A, which is the same as M, is 0.275. Now, a cool thing, the ordered pair 0, 1. Let's remember a fact about linear functions, or just lines. When the x value is 0, the number that comes after it is b. And the reason that should make sense, the only way an x value can be 0 is if you're standing on the y-axis. So for a line, if the x value is 0, the y value that they're giving you that pairs with it has to be the y-intercept, and another name for the y-intercept is b. So we have our linear function, our linear model, f of x equals 0.275x plus 1. Okay, part B. Estimate the number of SUVs sold in the year 1993. All right, our beginning year was 1991. That's sort of time 0. 1993 is 2 years away. So they're asking me, it's 2 years away from our beginning year. So they're asking me to put 2 into the function. F of 2 is 0.275 times the quantity 2 plus 1, which turns out to be 1.55, but we need to remember to tack on the unit millions, 1.55 million, because that wouldn't make sense if you didn't put on million. That would be crazy. Okay, the last question. Why shouldn't you use this model to estimate the number of SUVs sold in 2006? Well, in the very first sentence, it said that the sale of SUVs increased dramatically between 1991 and 1999. There's nothing in here to let you know that any demographics being data in the area, were collected after 1999 for you to perhaps change this model. So one of the things that I want you to remember, for those of you going on into statistics, when they give you a model to work with, and they're not all going to be linear, but when you're working with a model, one of the questions that you should present, or you should ask the person giving you the data for the model is, how long is this model good for? If you tell me a model's good forever, your model's worthless. Okay, we're done with section 5.1.